Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering the theory behind CSRF vulnerabilities. Now, similar to the SQL injection theory video, this video is pretty much a brain dump of everything that I know about CSRF attacks, and so it's going to be a long one. However, by the end of the video, you'll have all the background knowledge you'll need to complete the hands-on exercises, which we'll cover in the next upcoming videos. For today's agenda, the first thing that we will cover is the technical details behind CSRF vulnerabilities. So what is a CSRF vulnerability? What conditions must be satisfied for a page to be vulnerable to CSRF? How common are CSRF vulnerabilities? And so on. Next, we'll cover how to find CSRF vulnerabilities from both a white box and a black box perspective. So if you're given an application and possibly even the application source code, how would you approach testing the application in order to determine if it's vulnerable to CSRF? Once you have found that the application is vulnerable to CSRF, how do you exploit it in order to achieve your end goal? Then we'll end the presentation by covering the different techniques that you can use in order to prevent CSRF attacks. Alright, let's start off with the first section. What is a CSRF or cross-site request forgery vulnerability? Before we can even cover the technical details behind CSRF vulnerabilities, we need to understand how session handling or session management is done in traditional applications. And in order to understand how it's done, we'll use an example. Imagine you have a user and the banking application. The user needs to access the banking application. So the first thing that the user is going to do is supply the banking application with his credentials, which would be his username and password, which in this case is admin. The application then sets a cookie in the user's browser. Now, a cookie is simply a text file that contains some information that identifies a user to the backend. For the majority of applications, the cookie value is just a long random string that is not easily guessable, just like the one you can see in the example over here. However, as you gain more experience and get exposed to more applications, you'll notice that some applications make use of cookies that contain user identifiable information, like the user's username, the roles that the user has in an application, and so on. Now, session management or session handling itself is a whole topic on its own, and so we're not going to discuss it in this video. Instead, we're going to just learn enough in order to understand how CSRF vulnerabilities work. And all we really need to know is once the user supplies his credentials to the application and the application sets a cookie in the user's browser, that cookie will be what identifies the user in all future requests. And so how does that happen in the backend? Well, when a user accesses a domain that he has accessed before, the browser checks the cookie jar, which contains all the cookies of the applications that the user has visited. The browser asks the cookie jar, do you have any cookies for so-and-so domain? If the cookie jar has any cookies that are assigned for the requested domain, then the cookie gets sent with the request. Now, when the backend receives the session cookie, it checks which user is assigned to this cookie. Now, in this case, the user that is assigned this session cookie over here is a user with the name user. The next thing that the application does is check the permissions that this user has. And if this user has permission to access the resource that was requested, then the resource is presented to the user on the browser. If the user does not have permissions to access the resource that was requested, the user is presented with an access denied message. And that's all we really need to know in this video about session management, and it'll become clear in a few slides why you need to know that piece of information. Alright, let's discuss cross-site request forgery, or in short, CSRF vulnerabilities. A CSRF attack is an attack where the attacker causes the victim user to carry out an action unintentionally while the victim is authenticated. So a really important prerequisite for a CSRF attack to be successful is that the user has to be already logged into the application, and that's represented in this example using the cookie icon. So we assume that the victim user has already provided his credentials to the application responded by setting this cookie over here in the user's browser, and now every time the user visits a page in this domain, the session cookie gets sent with that request, and that's what authenticates or identifies the user to the web application. Alright, going back to CSRF. The first step of a CSRF vulnerability is to send the victim user a malicious link that will conduct the CSRF attack. So in this case, our attacker sends the victim user an email that says click on this link. And if we look at the link over here, it's for the domain bank.com, which is the web application that the victim user is logged into. And then we have a /email/change, and it changes the email address of the user. Now, if the attacker clicked on this link in his browser, all this link does is it changes the email address of the attacker. So it'll change the email address of the attacker from one email address to another email address. However, if the attacker successfully gets the victim user to click on this link while the victim user is logged into the application, then the attacker will be able to successfully get the victim user to change his email address to one of the attacker's choosing. So let's see how that works. When the victim user clicks on this link, the browser goes to the cookie jar and asks, hey, do I have any cookies for this domain over here? The cookie jar responds and says, yes, I'm already authenticated to this domain. Here's the cookie for this domain. And so when the user clicks on this link over here, the session cookie of the victim user gets sent with the request. So when the backend receives the request, it sees that the user that is assigned this session cookie requires that the email address be changed on his account to the email attacker@gmail.ca, and that change occurs. And what we're really doing over here is exploiting the default functionality of the browser to automatically send cookies to the assigned domains. And so now that the email has been changed, what the attacker can do is use the forgotten password functionality in the application and request a password reset. And since the attacker had already changed the email address of the victim user account to one that he controls, the forgotten password email will get sent to the attacker's email, and then the attacker can use it to reset the password of the victim user and completely compromise the account. So with one click from the victim user, the attacker was able to fully compromise the victim's account. Now, you might be wondering, well, if I'm a victim and someone sends me an email that contains the domain of my bank and clearly says that this request is changing the email address to an email address that I don't know, I wouldn't click on the link. And that's a really, really valid comment. However, in the real world, the attacker won't simply send you the link that conducts the attack. Instead, what the attacker would do is create a malicious website that looks innocent and hosts something that interests you, which in this case is really cute cat images. And while the victim user is looking at the cat images, in the background, what's happening is there's a script that is executing within an invisible iframe that you can't see, and that script changes the email address on your behalf. As long as you're logged into the application, this entire process happens in the background without you even knowing. And we'll gain hands-on experience in 8 labs performing this exact attack without the victim user even knowing that this even happened. So while the victim is looking at cat images, in the background, the attacker had fully compromised the user's account, and the user won't know until the user tries to log into his account and no longer be able to because the attacker changed the password. Alright, we talked about 2 conditions that are required in order for a CSRF attack to be delivered successfully. One is that the attacker has to send an enticing email to the victim that the victim user is going to click. And 2, when the victim user clicks on the link, the victim user has to be already authenticated into the vulnerable application. Now, before we even deliver a CSRF attack, we need to confirm that the functionality in the application that we're exploiting is actually vulnerable to a CSRF attack. And the way you confirm that it's vulnerable to a CSRF attack is it has to satisfy 3 key conditions. The first one being a relevant action. So the way we define a relevant action is an action that if it were to be exploitable, it would cause detrimental effect to the victim user. So in this scenario over here, the action is the email change functionality. And we saw that if an attacker is able to exploit this vulnerable functionality and change the email address to one that the attacker owns, then the attacker can use it in order to fully compromise the victim's account. And so this causes detrimental effect to the victim user, which means that it satisfies the first condition, which is it's a relevant action. The second condition is cookie-based session handling. So the application has to be using cookies for session management. And the reason it has to be using cookies is because this whole attack is built on exploiting the default functionality in the browser that automatically sends cookies to the assigned domains when a request is made by the user. So in this scenario, when the victim user clicked on the link over here, the browser went to the cookie jar and asked, hey, do I have any cookies for the domain bank.com? The cookie jar responded with, yes, I am already authenticated to this application. And so when the victim user clicked on the link, the cookie was sent with the request authenticating the user into the application. If cookie-based session handling was not being done in the application, this entire attack won't work. And that's why it's one of the conditions that are required in order for a CSRF attack to be possible. The last condition is no unpredictable request parameters. So in this scenario, we had only one request parameter, which is the email address, and that's clearly predictable by the attacker upfront because it should contain the email address that we want to change to. And so we know it upfront. Now, if the request required another parameter that is unpredictable, such as what is known as a CSRF token, and we'll learn about that more when we talk about how to defend against CSRF attacks. But if it contains an unpredictable request parameter, then when the victim user clicks on this link, the browser is going to apply the same process. It's going to ask the cookie jar, hey, do I have any cookies for domainbank.com? The cookie jar is going to respond yes, and the request will be sent with the victim user session cookie. However, when the application gets the request, the application is going to deny the request because the request does not have all the required parameters. And since the attacker can't predict the request parameters upfront, the whole attack will fail. And that's why in order to defend against CSRF vulnerabilities, we include another parameter called a CSRF token that is unpredictable to the attacker. And so when the attacker tries to conduct a CSRF attack, the application rejects the request because that CSRF token is not available within the request that the attacker had sent. Alright, so to recap, you need 3 conditions in order for a CSRF attack to be possible. The first one is a relevant action, the second one is cookie-based session handling, and the third one is no unpredictable request parameters. If you're missing any of these conditions, then the functionality that you're looking at is not vulnerable to CSRF. And I see this mistake happening a lot in the bug bounty world where vulnerabilities get submitted to programs saying that certain functionalities are vulnerable to CSRF. However, they don't satisfy all 3 conditions. And the most common example that I see is not satisfying a relevant action. So in this case, the email change functionality allows for full compromise of the user's account, and so it's relevant. However, if you're looking at a logout functionality or a change language functionality, even if it satisfies the last 2 conditions, it's still not vulnerable to CSRF because it's not a relevant action. If you as an attacker get a victim user to click on the link, the most effect that you will have on the victim is that you log the victim out of his account. And so the victim can just log back in, or you change the language of the application from English to French. And in this case, the victim user clicks on the English icon and goes back to navigating the website. So exploiting these functionalities does not have any advantage to the attacker, and it has very minimal effect to the victim. And that's why they don't qualify to be relevant actions, which makes them not vulnerable to CSRF. So you need to be really careful when you're reporting CSRF vulnerabilities that they satisfy these 3 conditions that are listed on the slide. Alright, so we covered the technical details behind CSRF vulnerabilities. Now let's talk about the impact of CSRF attacks. The impact really depends on the functionality in the application that is being exploited. So the example that we looked at in the previous exercise, exploiting the email change functionality, caused a full compromise of the user's account, and so the impact was pretty high. If you compare it to CVSS scoring, when it comes to impact scoring, the CIA triad would almost be all high. So confidentiality would be high, integrity would be high, and availability would be high. However, if you're exploiting a CSRF vulnerability which allows you to only change text in the application, then confidentiality would be none because you're not actually exposing any confidential information about the user. A CSRF attack is not able to do that because of something called the same origin policy, or in short, SOP, and we'll talk about that when we get to the course module. Integrity is partial because you were able to change the text in the application, and availability is none because you don't impact the availability of the application to the user. The user still can log in, the user still can perform all the tasks that he or she needs to do, and so availability is not impacted at all. And that's why I say it really depends on the functionality in the application that is being exploited. It could be all the way from a really high vulnerability, a 10.0 rating, to a low vulnerability. And of course, the worst impact that could happen is remote code execution on the server that is hosting the application. And I've seen that happen with CSRF attacks before in two scenarios. The first one being chaining two vulnerabilities together. So you start off with a CSRF vulnerability, and then you chain it with an SQLI or a command injection that allows for remote code execution. The second scenario that I've seen it in is where the application, if you have really high privileges, by default has functionality that allows for code execution on the server. For example, WordPress, if you were an admin on a WordPress site, or if you were an admin on Jenkins, then you could use certain functionalities in those services in order to gain remote code execution. And so all you need to do is conduct a CSRF attack on a user that has these privileges, so the administrative privileges, and then you could combine that with the intended functionality in the application in order to gain remote code execution on the server. All right, so how common and how critical are CSRF vulnerabilities? One way to measure that, and it's not bulletproof, is to use the OWASP Top 10 list. For those of you that have never heard of the OWASP Top 10 project, it's essentially the list of the top 10 most critical security risks in web applications. It's community driven by professionals, and it's updated every couple of years. So I've got over here the 2010 version, and then the 2013 version, and the 2017 version, which I believe is the latest version that is available. And you'll see over here, cross-site request forgery was the 5th most critical security risk in 2010. In 2013, it dropped and it became the 8th most critical security risk. And then in 2010, it completely disappeared off the list. And the reason for it no longer becoming one of the most critical security risks across the years is because now modern frameworks by default defend against CSRF vulnerabilities. And so you have to go out of your way to either disable the defense or introduce vulnerable code that bypasses these defenses. And you might think, well, that's great. That means we won't find CSRF vulnerabilities in modern applications. But that's not true. You'd be surprised at the CSRF vulnerabilities that are found in big name applications every year. And we'll see examples of that in the lab, how these CSRF vulnerabilities could be introduced, although the framework has built-in default functionality that defends against CSRF vulnerabilities. Alright, so we discussed the technical details behind CSRF vulnerabilities and the potential impact of exploiting a CSRF vulnerability. Now let's talk about how you would go about finding this class of vulnerabilities. A quick disclaimer before we start this section is that my methodology might be a bit different from someone else's methodology, and just because it's different doesn't mean it's superior. So the way I approach developing my own methodology is I start off with a base methodology that I've learned from either a book or a course or a person, and then I build and expand it as I gain more experience in testing web applications. And I'm hoping you also do the same. So take my methodology if you don't have one yet, and build on it as you gain more experience. Alright, so when I'm describing my methodology for testing web applications, I always describe it in two different perspectives. The first one is if I'm testing from a black box perspective, and the second one is if I'm testing from a white box perspective. So a black box perspective means that you're given the URL of the application and possibly credentials to the application. The best scenario is that you're given credentials for each access level of the application. For white box testing is you're not only given the application, but you're also given access to the source code of the application. And so you have more visibility about the inner workings of the application. Now for black box perspective, when I'm looking for any vulnerabilities, not just for CSRF, my number one recommendation that you do is map the application. So review all the key functionality in the application and make note of all the key functionality. Once you've made note of all the key functionality, identify which of these functionalities satisfy the three conditions that we talked about in the previous slides. So 1, it has to perform a relevant action. 2, the application has to be using cookie-based session handling. And 3, there has to be no unpredictable request parameters in the page that is vulnerable to CSRF. As long as it satisfies all three conditions, then it's definitely vulnerable to CSRF. However, you also need to confirm that because some applications have unconventional defenses for CSRF vulnerabilities, and we'll talk more about that when it comes to the last section. And that's why it's always good to create a POC or a proof of concept script to show that the functionality is vulnerable to CSRF. Now, in the scenarios where I've seen that there were secondary defenses to defending against CSRF vulnerabilities, the defenses were almost always inadequate. And what I mean by inadequate is they could either be bypassed or exploited in order to achieve your end goal, which is exploit the CSRF vulnerability. So you should never use an unconventional defense. Use the recommended defense for CSRF, which is adding CSRF tokens to requests that perform sensitive actions. All right, so when you're creating the POC script, you'll encounter one of two situations for the most part when it comes to applications. One is the request being made is done using a GET request. In this scenario, in order to exploit the CSRF vulnerability, you can do that using an image tag where the vulnerable URL is in the SRC attribute of the image element. The second scenario is using a POST request. In that scenario, you would use a form element with hidden fields for all the required parameters in that request, and then you set the target attribute to the vulnerable URL. If that doesn't make sense, that's okay. In the next section, when we talk about how to exploit CSRF vulnerabilities, we'll have examples for each one of these use cases. All right, so that's how I would go about finding CSRF vulnerabilities from a black box perspective. Now let's discuss a white box perspective. So I've never approached finding CSRF vulnerabilities from a pure white box perspective. And the reason behind that is because it's just really easy to find it from a black box perspective versus a white box perspective. However, imagine a scenario where the client only gives you access to the source code and not a running application where you could do maybe a gray box pen test. So it's purely a white box pen test where you're only given the source code of the application and you can't test the application from a black box perspective. In that scenario, what I would do, which again, I've never done before, but if I was presented with that scenario, the first thing that I would do is read the code to identify the framework that is being used by the application. And the reason I do that is because modern frameworks have built-in defenses for CSRF vulnerabilities. And so as long as I know the framework that is being used, I can find out how the framework defends against CSRF attacks instead of having to figure it out on my own by looking at the code. And once I find out how the framework defends against CSRF attacks, which is really just a Google search, I would review the code to ensure that the built-in defenses have not been disabled. So sometimes developers disable these defenses because they're integrating with other applications and it breaks some of the integration, and so they think it's okay to disable the defense. However, that introduces an attack vector when it comes to this vulnerability. And so you should never do that. But nevertheless, if you're looking from a pure white box perspective where you don't have access to the application, you could start off by identifying the framework, figuring out how the framework defends against CSRF vulnerabilities, and then reviewing the code to ensure that the built-in defenses have not been disabled. Now, that's not enough to ensure that all the functionality in the application is not vulnerable. And the reason behind that is some developers introduce custom code or for certain functionality disable that defense. And so the last step that I would do is review all the sensitive functionality to ensure that the CSRF defense has been applied. And a quick example that we'll see in one of the lab videos is when the developer has not disabled the built-in defense. However, the application allows for a user to change a post request into a get request, and the application accepts that request. So in this scenario, the built-in defense adds CSRF tokens to all post requests because by design, you should only submit data to the application using a post request and not a get request. However, in this scenario, the application allowed get requests to submit data to the application. And so to bypass this built-in defense, all we had to do in the lab exercise was change the request from a post request to a get request, and then the CSRF token was no longer required. And that's why I always say review all the sensitive functionality to ensure that the CSRF defense has been applied on all the key functions. And that pretty much sums up how I would find CSRF vulnerabilities from a white box testing perspective. Alright, so far we've talked about the technical details behind CSRF vulnerabilities. We talked about the impact of exploiting a CSRF vulnerabilities, and then we talked about how to find CSRF vulnerabilities from both a white box and a black box perspective. Now imagine you found a CSRF vulnerability. How do you go about exploiting that CSRF vulnerability in order to achieve your end goal? For the majority of applications, you'll encounter one of two scenarios. The first one is where it's a get request that is being performed, and the second one is when it's a post request that is being performed. Now, I'll reiterate, you should not use a get method in order to submit data to the application. It's against the standard and it introduces potential attack vectors, and so you should never do it. But in this scenario, the developer is using a get method in order to change the email address of the user on the system. And this is a real example from one of the labs that we'll look at in the lab videos. So we've got bank.com/email/change, and then the email address you want to change to. So in order to exploit this vulnerability, we need to get a user to click on an application that has a script inside of it that performs this request over here, except the email needs to be the attacker's email. So the script will look something like this. This is the exploit over here. It's an HTML element because it's an HTML page that will be used to run the exploit. All the user sees is a heading element, hello world. So this is what the victim sees when the victim clicks on the link. But in the background, what's happening is there's an image element. So you could see over here, the width is 0, the height is 0, and the border is 0. That means that the image is invisible to the user on the page. And that's why the user can't see the image at all on the page. And what the image does is it has an SRC attribute that links to the email change functionality. So we've got bank.com/email/change, and then the email address of the attacker, which is attacker@gmail.ca. Now, when the user clicks on this HTML document, the user only sees the message hello world. However, what's happening by the browser is the browser tries to load this invisible image, and the source of this image is this URL over here. So the browser visits this URL. If the user is logged into the banking application while the user clicks on this link, when the browser tries to load this image, this URL is visited and the whole process that we learned about gets applied. So the browser asks the cookie jar, do you have a cookie for the domain bank.com? The cookie jar will say yes because the user is authenticated, and then the request will be made with the session cookie of the victim user, and the email address of the victim user will be changed to attacker@gmail.ca. And then the attacker will use the forgotten password functionality in order to reset the password of the victim user account and fully compromise his account. All right, so the second scenario is a post scenario. So when you're submitting data to an application, you should be using post requests. That's the standard, and that's what the developer is doing in this application over here. So the host of the application is bank.com, and the path to the email change functionality is email change, and the parameter that it takes is the email that you want to change to. So in this case, if we put test@test.ca, the email changes from this one over here to the one that is in the request. And the way you would go about developing the exploit for post requests that are vulnerable to CSRF is as follows. So we've got the exploit script over here. Again, it's an HTML element. It has a heading tag, hello world. This is what the user is going to see. And then you use the form element in order to submit the request. So in the previous example, if we go back, the developer was using a post method and a form element in order to submit the email, and that's why we use it in our exploit as well. So we've got a post request, and the action is to change the email address. And then it takes in the parameter over here, so the input element, the parameter email, and the value is test@test.ca, which in this case would be our attacker's email address. Now notice over here, the target of the form is CSRF iframe. And the reason we do that is because it tells the form to run within an invisible iframe element. And so this way, the user, when he clicks on the website, he does not get redirected to the email change functionality and find out that the email address was changed. So instead, what happens is it runs in an invisible iframe element without the user even knowing, and it changes the email address. And the script over here, document.getElementById, CSRF form, which is our form that performs the CSRF attack, the .submit automatically submits it when the page is loaded. So all the user sees again is hello world, whereas in the background, what's happening is this form over here is being submitted in an invisible iframe, and the email address is getting changed in the background without the user even knowing. And we've got 8 lab videos coming up where we script the exploits on our own. So you'll get a lot of hands-on experience on how to write exploits when it comes to conducting CSRF attacks. All right, so we talked about how to develop your script manually when exploiting CSRF vulnerabilities. It's worth mentioning that there are automated tools that you can use in order to exploit CSRF vulnerabilities, and I have 6 of them listed on the slide. Some of them are paid, whereas others are free. I personally use Burp Suite Pro, and the nice thing about Burp Suite is it has a feature called the CSRF POC generator that allows you to generate an exploit for a request that you think might be vulnerable to CSRF. And this is a slide from one of our labs where we perform this attack. So all I had to do was right click on the request and then click on engagement tools and then generate a CSRF exploit, and then it generates the exploit for you over here. And then you could test it in the browser to see if the application is really vulnerable to CSRF. And we do both scenarios in the lab. So the first part of each lab video, we use the CSRF POC generator in order to exploit the vulnerability. And then in the second part of the video, we script the exploit on our own. So if you don't have the professional version of Burp, don't worry. It's really easy to write CSRF exploits, and we'll learn how to do that in the lab videos. Alright, so far we've learned about what CSRF vulnerabilities are, how to find CSRF vulnerabilities, and how to exploit CSRF vulnerabilities. We're going to end the video by learning about how to defend against CSRF attacks. So just like with any other class of vulnerabilities, we have primary defenses, secondary defenses, and inadequate defenses. Primary defenses are the defenses that you should definitely apply in order to mitigate the vulnerability. The additional defenses are defenses that you can apply in addition to the primary defense. And inadequate defenses are defenses that you see being applied in real-world scenarios. However, they're called inadequate because they can usually be bypassed in order to achieve your end goal. So let's start off with the primary defense, which is the use of CSRF tokens. A CSRF token is a randomly generated long string that is passed as a parameter in the request and is tied to the user's session. So remember when we said that in order for a functionality to be vulnerable to CSRF, it has to satisfy 3 conditions. The first one being that the functionality has to be performing a relevant action. The second condition being that the application has to be using cookie-based session management. And the third condition is that there has to be no unpredictable parameters in the request. In this scenario, by adding a CSRF token, we no longer satisfy condition 3 because we introduced an unpredictable parameter that can't be predicted by the attacker upfront. Of course, in order for this to be a proper defense, it needs to be implemented correctly. So the things to consider when generating CSRF tokens are 1, they have to be unpredictable with high entropy similar to session tokens. So essentially, they have to be a long, random string that is not easily guessable by an attacker, such as the one that you could see on the slides over here. The second thing is that the token has to be tied to the user's session. So the CSRF token over here has to be tied to the user's session in the backend. And the reason we say that it has to be tied to the user's session is because if it's not, what an attacker can do is use his own account, which he created on the application, in order to generate a CSRF token and then use that CSRF token in the attack. Now, when the attacker gets the victim user to click on the link, the request submits the session ID of the user and the CSRF token of the victim. Since both values are valid, the request passes through. However, if they were tied together, what would happen in the backend is it'll check, is this CSRF token that I'm given tied to this user session? And it won't be because this is the CSRF token of the attacker. And then the request is rejected. So you need to ensure that it's tied to the user session, and we'll see an example of that in one of the lab videos. The third condition is it has to be validated before the relevant action is executed. So before the email change happens, the application needs to confirm that this is a valid CSRF token, and this is the CSRF token that is tied to this user session. Once those two conditions are satisfied, then the email change occurs. If the two conditions are not satisfied, the request should be denied and blocked. All right, the next thing to consider is how these CSRF tokens are being transmitted. There are two ways to securely transmit CSRF tokens. The first one is using a hidden field of an HTML form that is submitted using a post method. So you could see in the example over here, the CSRF token is being passed as a parameter in the request. Now, if you were to go to an application that has this defense and then view the source code, you'll see that the CSRF token is in a hidden parameter, so a hidden field of the HTML form. And when the user submits the form, it gets passed as a parameter in the form. The second way to securely transmit CSRF tokens is using a custom request header. However, this is not very common. The two other ways are less secure ways of submitting CSRF tokens. The first one is when tokens are submitted as parameters in the URL. And the way we say that this is less secure is because, one, someone who's standing behind you can see the URL of the application that you're visiting. And so just like you wouldn't put a password in a URL, you shouldn't put a CSRF token in the URL. The second reason it's insecure is because URLs are usually logged in the backend. And so if you're logging URLs and you're transmitting tokens as queries in the URL, then the logs are filled with all the user's CSRF tokens. And the third condition why it's less secure is because URLs get transmitted as part of the referrer header. So any third-party application that you visit after you've logged into your application could potentially gain access to your CSRF token. And that's why it's considered less secure. The second one are when tokens are transmitted as cookies. So you should never submit CSRF tokens as cookies because just like we saw in the previous slides, the cookies by default are being submitted to the browser when the user clicks on a link. And so if you add it as a cookie, the attacker no longer needs to know the CSRF token up front because when the user clicks on the link, the browser is going to go to the cookie jar and say, hey, do you have any cookies for this domain? And the cookie jar is going to answer, yes, I have two cookies, the first one being the session cookie and the second one being the CSRF cookie, and they'll both be transmitted with the request and the request is going to be accepted. And that's why you should never include CSRF tokens as cookies, and you should include them as parameters in the form. Now, there is a scenario called the double submit cookie or the double submit defense, and it's used for applications that are stateless, so they don't store session information in the backend. And so the way these applications defend against CSRF attacks is they include a CSRF cookie. They also include a CSRF token. As long as both the cookie and the token, which is the parameter over here, are equal, the request passes through. If they're not equal, the request does not pass through. So let's take this from the point of view of an attacker. Now, if an attacker sends a link to the user, the CSRF cookie will be automatically sent with the link. However, the attacker does not have the parameter value in order to include in the request, and so this will be missing. Now, when this request gets received by the application, it'll check, is this CSRF cookie equal to this CSRF token? It's not, and so the request is rejected. However, this becomes a less secure way of defending against CSRF tokens when you have another vulnerability in the application, such as an HTTP header injection. So if you have an HTTP header injection in the application, you could inject a cookie into the user's browser and then add the same value of that cookie as a CSRF parameter. And this way, when the application looks at the request, it'll see a cookie, it'll see a CSRF token, and they're both the same value, and it'll accept the request. And we do have a lab in one of the videos where we have a double submit defense, and we exploit it by chaining a CSRF vulnerability with an HTTP header injection vulnerability. All right, the last thing to consider with CSRF tokens is how should CSRF tokens be validated? So the first thing you need to ensure is that they're generated and stored on the server side within the user session data. So they should be generated on the server side, not on the client side, and they should be tied to the user session. And when performing a request, a validation should be performed that verifies that the submitted token matches the value that is stored in the user session. So when a request is submitted, you need to ensure that that token that you receive over here is equal to the one that is stored in the user session. Next, validation should be performed regardless of HTTP method or content type of the request. So whether this is a POST request or a GET request, you should always validate CSRF tokens. And the reason we say that is because some applications allow for you to change the request method, and so change it from a POST request to a GET request. And if tokens are not validated for GET methods, then automatically you become vulnerable to CSRF. And again, this is another exercise that we'll be seeing in the upcoming lab videos. And the last one is if a token is not submitted, the request should be rejected and logged. So if you don't have a valid token or the token is omitted from the request, then you should reject the request and you should log it because it's a possible attack. All right, so that's a primary defense to defend against CSRF attacks. Now let's look at the additional defense. So the secondary defense, which is not used very often, makes use of same-site cookies. The same-site attribute is added to the setCookieResponse header when the server issues a cookie, and the attribute can be given 3 values, either strict, lax, or none, as can be seen in the figure on the slide. Strict means that the cookies will only be sent in the first-party context and not be sent along with requests initiated by third-party websites. So if the request is initiated from a third-party website, then the cookie will not be submitted with that request. So if we go back to our attack, the request is sitting on the malicious site of the attacker. And so when the user clicks on the site and the request is initiated, the browser checks to see if this request was initiated from bank.com or was it initiated from a third-party website. In this case, it's a third-party website, which is the malicious site that the script is hosted on. And so the session cookie is not sent with the request. And because the session cookie is not sent with the request, the application is going to reject the request as if you're an unauthenticated user, and the CSRF attack won't work. Now, this is called strict because it is the strictest option when it comes to same-site attribute, and it's usually not really used because it does impair user experience. Because if you have an application that integrates with third-party applications and sessions need to be managed across these applications, then the session cookie won't be sent to these third-party applications, and the third-party application will view the user as a logged-out user versus an authenticated user. And so it impairs user experience, which is why most applications don't use this configuration. There is a less strict configuration called lax, and lax will include the cookie in requests that originate from another site, only if 2 conditions are met. The first one being the request uses a GET method. Requests that use any other method, such as the POST method, will not include the cookie. And the second one is that the request has to have resulted from a top-level navigation by the user, such as clicking a link. So if we go back to our attack where there's a malicious script on the site that automatically submits the request, this way that the request is being initiated by a script and not by a user, and so the cookie won't be sent with the request. So to recap, for the lax option, it only sends the cookie to a third-party website if 1, the request uses a GET method, and 2, the request resulted from a top-level navigation by the user and was not initiated by a script. The third option, which is the none option, means that cookies will be sent in all contexts. So it will be sent to both first-party and cross-origin requests. This is as equivalent as you not having the same site attribute at all. you definitely can't use this in order to defend against CSRF attacks. The best configuration to defend against CSRF attacks is using the strict option. If you can't use it, then you use the lax option. Of course, you need to use that as an additional defense to CSRF tokens and not as a defense on its own. All right, the third defense, which we called an inadequate defense, is the use of a referrer header. So the referrer header contains either an absolute or a partial address of the page making the request. So it tracks where the request comes from. The way applications usually defend against CSRF, which is an incorrect way, but the way they usually defend against CSRF is they check to see if the referrer header is equal to the domain of the application. If it's equal to the domain of the application, that means that the request originated from the application itself, and so it accepts the request. If it's not equal, it rejects the request. Now, the reason we say it's insecure is because referrer headers can be spoofed. This is not an easy attack to do, and you have to have certain conditions satisfied before you can actually spoof a referrer header. However, it's possible, and that's why you shouldn't use it as a defense against CSRF attacks. The second reason is usually the way it's implemented can be bypassed. So I've seen two examples, and we'll see both examples in the lab videos. The first one is if the referrer header is present, it'll check it. If it's not present, it won't check it. And so what we do in one of the lab videos is we remove the referrer header completely, and all of a sudden the application accepts the request. The second example is when the application is only checking to see if the domain exists in the referrer header or is contained in the referrer header. As long as it's contained, then it accepts the request. If it's not contained in the referrer header, it rejects the request. However, the way you could exploit that is you could just include the domain of the application as a query parameter in a URL. So what you could do is say www.maliciousSite.com/? and then bank.com. When it reaches the application, all the application is checking is bank.com in the referrer header. It is, and so it accepts the request. And the issue over here is that instead of doing an exact match, it's just doing a substring match within the referrer header. And that's pretty much it for using referrer headers as a defense. So to recap, the primary defense is to use CSRF tokens. The secondary defense is to use same site cookies. And a defense that you definitely don't want to apply is the use of the referrer header. All right, that concludes our video. Before we end the video, I have a few resources on the slides that you could refer to in order to gain a better understanding of CSRF vulnerabilities. The first one is the Web Security Academy, which is what this slide is based on and what the lab videos will be based on. The second one is the Web Application Hackers Handbook. So they have a chapter called Attacking Users, Other Techniques. And within that chapter, there's the section about CSRF. And then the last three links are OWASP links that talk about what CSRF vulnerabilities are, how to find them, and how to prevent them. In the next upcoming videos, we'll gain hands-on experience on how to exploit CSRF vulnerabilities.